Good afternoon and welcome back to the OpenStack Now podcast. This is episode 9. I am here with my co-host John Jainschigg. I am Nick Chase, and we are here with our guest, Director of Solutions Architecture for Metaswitch and Chief Architecture for Project Calico, Christopher Liljenstolpe.
Hello,
right?
everyone.
Hello.
Okay, great. So,
and you congrats on the name. You got it right. That's
Thank you.
It's not an easy one.
Yes, it definitely is not. I want to thank everybody for joining us. As you can see, we have John has wrested technical control back from me, and we are now back to our previous format. We'll see how that goes. But thank you so much for joining us. So this is an area where John has a lot of interest. So John is going to drive things today. So take it away, John.
Well, I should explain that my expertise here is not so much in networking, but in posting fuel plugins to the Mirantis fuel plugins catalog, which I had the pleasure of doing last week for the Calico plugin. So now in Mirantis OpenStack 6.1, you can get a Calico plugin that will facilitate deployment of Calico pure level 3, layer 3 networking with a Mirantis OpenStack 6.1 cluster. Which brings us to, and of course, this is a set piece question. What is Calico?
So, simply put, Calico is a non-overlay. It's a natively routed infrastructure. If you take a look at most of the other OpenStack based networking infrastructures, you basically emulate L2 segments or lots of L2 segments, and then you encapsulate them in layer 3. So you've got L2 switches and tunnels and a whole lot of state and multiple layers of network to basically deliver IP connectivity to endpoints. There's very few IPX or AppleTalk or DECnet networks around anymore. The applications are speaking IP. So why not just go back to base principles and route these endpoints rather than trying to L2 switch them and encapsulate them. And that's basically what Calico does. We turn every compute server, every Nova server, into a router for the VMs or containers that are hosted on that server. So no overlays, native IP networking end to end.
So this has, I would think, pretty obvious benefits to achieving extreme scale. Doesn't it? Because you're taking it up above the level of the top of rack switch, and you're, in principle, making it possible to federate clusters together relatively easily via BGP and other things.
Sure. I mean, this is leveraging my background is big internet backbones. I've built a number of big internet backbones in my life. If you take a look at this looks a lot like an internet backbone architecture that's brought into the virtualized data center or pod or cluster or supercluster. And that was on purpose. We know this network design scales. We know that BGP networking and IP routing infrastructure scales at very large scales. It's the public internet, after all. So it's simpler. There's a lot less state. There's a lot less moving parts. If you want to get things to scale, you do it simply. You reduce the amount of state. You distribute that state so that things are acted locally rather than via some central on-high view. And that's what Calico does. So yes, scale, simplicity, ease of troubleshooting. Those are some of the big advantages of Calico.
What doesn't it let a person conveniently do? I mean, there must be a reason that mixed layer networking SDN paradigms, are commonplace.
I think this is a two-part question. To answer your second part first, I think a lot of what we've done in virtualized networking to date has just been basically cribbing from the past. So if you take a look at enterprise networks, they were built with Ethernet segments and firewalls between the tiers, etc. When VMware came along, it tried to replicate that enterprise design pattern to make it easy to move into a virtualized world from a physical server world. OpenStack sort of did the same thing. Just keep that pattern because it's a pattern that enterprises understand. However, enterprises don't work at the scales people are now talking about. So to a certain degree, we're here because we just followed a blueprint that's been existing for decades in the enterprise world. So I think that's one of the reasons why we're here. There are some things that Calico does not natively do that may cause issues. If you need to do non-IP workloads, and by that I don't mean private IP workloads, I mean things like AOE or FCOE, those kind of things, more Ethernet specific protocols where there's not an IP packet. That's not going to work in Calico. You're going to have to do some kind of tunnel over the top of Calico, which you can do. Just like you can tunnel L2 over IP in the public internet.
So at that point, you're tunneling Ethernet over IP.
Correct. Versus what we do now, which is tunneling IP over Ethernet over IP over Ethernet, which is the stack that we do today in Optimus. And somewhere in there's a payload. 10,
when you say it that way, I can see
bytes,
why we want to abandon this. Right?
Yeah, 1480 bytes a header and 20 bytes a payload. But the other,
I can't imagine why we have issues.
Nah, couldn't be. It's the other thing that Calico doesn't support right now, but we have a plot for, is overlapping addresses. So if you want to have two sets of VMs that use the same address space, in Calico natively today, that's not supported. We have a design to do that using 4-to-6 translation, which we believe is pretty slick. One of the reasons we haven't done it yet is when we actually go out and talk to people who are deploying Calico and say, is this something you actually need right now? The answer comes back is, well, we'll need it at some point, maybe, but not now. So I think that also puts paid a little bit to everyone thinking that you need to support private IP addressing, as in overlapped addressing. You can use you can use 1918 space in Calico. You can use v4 or v6 in Calico. It's fine. But if you want to overlap the addresses, some people think that's really important, but when we actually go out to talk to the folks who are actually running these fabrics, it doesn't seem to be as important as people think it is.
Would that be significant if, it sounds like the kind of thing that would be significant if one had two separate clusters with highly elaborate application deployments on them, which happen to overlap, and you want for some reason to bring them together. Is that an example, or have I?
That is an example. Another good one is mergers and acquisitions activities, and you bring in an application stack from someone who you've merged with. The interesting thing, though, that we're seeing is that more and more, it's very rare to find today applications where people have hard-coded addresses in, where you don't use DNS or some other kind of service discovery mechanism to find things. And the minute I've done that, readdressing applications is not a huge deal. And I think that's where we're seeing this, is people are realizing that, yes, if I bring in a 15-year-old application into my cloud and that application has hard-coded addresses, I'm going to have a problem. But guess what? Trying to bring a 15-year-old application into a cloud...
It's not going to be your only problem.
It's not going to be your only problem. Possibly at which point... just, make the addresses, model design. Gee, DHCP and DNS, guys, it sort of works. But we do see there are some corner cases, and we do have a design for it. It's just, we're driven by what people want to do, and this is one that's not high on the priority list.
So Calico came originally out of Metaswitch's work,
correct,
and was open sourced by Metaswitch. And is that, were you the architect of the original?
Yes.
The original product?
Yes.
And so you transitioned smoothly, I guess, to your role, where maybe not smoothly, but there you are, into your dual role as architect of the open source part, and still, obviously in a position of high architectural responsibility at Metaswitch. What is that like? Living with those many hats on your head, I guess.
My joke is my day job consumes 5% of my time, and my other job consumes 95% of my time. So, Calico is something Metaswitch is really committed to doing and keeping in the open source world. So, for right now, this has become a major platform that Metaswitch sees that it can leverage. So we're not really in contravention. Most of the stuff I do for Metaswitch is helping more with more carrier-oriented things because I have a background in carriers, and also looking at how Project Calico can be integrated into Metaswitch offerings. So it's all sort of within the same milieu.
Now you have just released a version 1. Is that right?
Yeah. So we released version 1 for OpenStack. And so the way Calico works, it's the same code base. There is no commercial code base versus open source code base. It's one code base. It's all on Git. And the core mechanisms and the actors, the things that do the routing and the forwarding and the ACL and policy enforcement are the same across OpenStack or Docker or Kubernetes or any of the other containers we support. So really, the code is exactly the same. What changes is how we integrate to the orchestrators. So we integrate for OpenStack as an ML2 consumer, as a Neutron ML2 consumer and Nova consumer. By the way, with Calico from day one, for those of you who run ML2, we have a native v6 implementation that actually works. v6 networking worked from day one in Calico. So for those of you who actually have been reading the news and realize that North America is now out of IPv4 addresses, Calico can support you with v6. But so those orchestrators plugins, we've spent the most time developing for OpenStack. That was our first one. So we believe that module that plugs into ML2 is further along than, say, some of the ones that we use to integrate Docker and Kubernetes and other things. So the whole infrastructure, we believe, is very reliable. OpenStack 1.0 and the container stuff will follow in short order.
What happens when you are running something like Kubernetes, maybe with Docker on top of it, or Docker on standard hosts within OpenStack?
So the big question for us, because we actually refer to workloads in Calico. We don't care if they're VMs or they're containers. So really it all comes down to who is providing the orchestration. Theoretically, the architecture would allow us to talk to multiple orchestrators. And in fact, we've done a demo with CloudSoft where they've actually shown containers and VMs coexisting in a single infrastructure and that working. But if you look at, it's really, like I said, down to the orchestrator. If it's OpenStack that's orchestrating those containers and those VMs, it will look no different than any other OpenStack VM. If it's Docker that's orchestrating, then the question becomes, is OpenStack just providing the VMs that Docker runs in? And at that point, Calico's dealing with Docker and sees the VMs as the physical servers.
I follow. So because you're locally routed, you have these routing entities, then you run the routing entity on behalf of the host or on behalf of Docker or on behalf of Kubernetes, right? Okay.
And I think the interesting thing there is that routing entity is really just a routing protocol engine, open source, and a tool that manipulates the ACL infrastructure. For the actual data path, we just use a standard Linux kernel. There's nothing new that gets installed. So what we actually instrument is the Linux kernel. There's no OVS. There's nothing else in here. You're using the same data path that all your traffic goes through anyway today.
So it's very efficient. I mean, it adds little overhead to packet switching that would happen anyway, and packetization and so on that would happen anyway.
Exactly. We're just manipulating kernel structures in the Linux kernel.
Huh. So is this why carriers are excited about this? Because it provides this fabric that you can imagine easily pasting NFV things on?
Yes, NFV brings with it all sorts of interesting things like service function chaining, which is a whole nother conversation, which we don't have time for here. But yes, carriers, people who are used to running at scale, see this. We had an interesting comment. So it's not just carriers. We also see a lot in the financial services and the other folks who are already operating at scale. And the comments we hear when we go do a lab deployment or whatever is, my God, that was easy. It just worked. We've had folks who have gone from native OpenStack, plain deployment of OpenStack, and had Calico up and running and passing traffic within an hour on tens of nodes, or 4 hours within tens of nodes. And the comments we get back is, this just works and it gets out of my way, so I can actually do what is interesting. So for a carrier, they don't want to have to screw with the network. They just want the network and the fabric to connect their containers or their VMs that are offering their NFV services. They don't want to have to spend time and resources managing that infrastructure as well as the applications on top of it. And so we just try and get out of their way as easily as possible.
That's very appealing. Considering the ferment of performance-based R&D that's going on in NFV, getting out of the way is probably the best thing you can do at this point.
It is. There's a whole large conversation in NFV is the right model going forward going to be scale up versus scale out? But there's that's a broad area of conversation. But yes, just making it simple and getting out of the way is important in either of those models.
You have yourselves run within the scope of the project proof of concept tests, and it's not entirely clear, I guess maybe just in my mind, in what circumstances those are run. Were those laboratory-based tests where you went to 10,000 VMs across 500 hosts?
Yes. So that's basically, we've been running those in both public cloud infrastructures as well as internally in our lab. We've also got customers that are now in lab tests up to hundreds of physical servers and large numbers of workloads sitting on top of those servers. So we've got external testing as well as public cloud and internal testing as well. And that's churning potentially, our goals are churning, say, 20 containers a second in a container environment up and down. And that just seems to be working for the most part. So,
well, how nice.
Yes. If you don't have to distribute a whole bunch of tunnel state, if it's literally just a route announcement when something comes up and tear down a route when it goes away and update some local ACLs, it becomes much easier to do things at scale and do things fast. So, as we go to containers from VMs, VMs last days, weeks, months. Containers may only last seconds. So if it takes me a huge amount of time to set up, a full mesh of tunnels from a given container, that container only lasts a couple of seconds. That's not really efficient.
So what are next steps for Project Calico?
We have, just like any open source project, a little bit of a backlog in features. There's going to be working on some of those features that we've been talking about to customers but haven't been highest priority, like Anycast HA models, V6 for handling V4 overlap. Those are probably some big things next on the list. Continued hardening of the container solution, so going to V1.0 on our containers and broadening the number of orchestrators for the container world we deal with. I think there's a broader conversation we'd like to be involved with in the OpenStack community about ensuring that layer 3 networking is a first-class citizen in Neutron, or in the application API model. Right? There is a certain amount of L2 bias today in Neutron, which we work around, but it'd be better if we could, remove network physical network building blocks from that API. So instead of somebody having to think about, I need to create a segment and I need to create a router and all those things, more of an intent-based model where a application owner can say, these things need to talk to these things with these characteristics. And that becomes a little more neutral as far as, is it rendered in L2 or is it rendered in L3? But I think that's a longer range thing. But I think as an industry, it's something we need to start thinking about.
Very interesting. And of course, likely to be a shrill and complicated discussion when it starts happening, right? Because, well, obviously,
shrill is one word that I would use. Yes,
people don't give stuff up easily if they're used to it. But also, there may be room for both models, and creating an abstraction framework that allows them to coexist gracefully is not, and it's not altogether an easy prospect.
It's not. But the thing that when we go out and talk to customers and users of this infrastructure and ask them, what some of their pain points are, as an example, if my application owner has to start thinking in terms of segments and routers and such, we will end up with the same. First of all, most application developers aren't networking guys. Right. So they're going to start.
For that.
So true.
So they're going to start trying to think about, well, what their understanding of a network is, which may not be the right way of doing things. More importantly, you end up with the classical firewall problem we have today. Sometime down the road, somebody's going to come through and see all of these rules in the firewall or all these rules in the L3 routing service that say connect this to this, but they're not going to understand the context. Why was this done? Was that router put there because they needed to connect two segments or to enclose a blast radius or to insert policy? So later, when somebody comes along to clean this up, they've lost all the context because the application owner thought in terms of these small network building blocks, and I don't know what their intent was. Instead, if somebody can publish their intent, coming through and cleaning it up later becomes very easy because I see what their intent was, that these things should talk to these things with these characteristics, rather than create an L2 segment here and an L2 segment here. Well, was that L2 segment because broadcast was necessary or because that's how they thought firewall rules should be done? So I think over time we are going to be incurring some technical debt if we continue to make people think in terms of specific building blocks rather than what is the requirement of the application. And I think this is one thing maybe where, I hate to say it in this community, where the container guys are maybe a little bit further ahead from the OpenStack guys, in that the container guys are very much about this intent-based model around containers, etc., and letting the application developers just think about the intent of their applications rather than the actual how it gets rendered.
Yeah, and the containers and the platform as a service community is, in general.
Right.
Makes a lot of sense to me. Nick, do you have any more specific questions?
I think you lost me about 20 minutes ago. No, I'm just I'm just kidding.
I don't know. This is really fascinating stuff to me. I think this is very important, and it's
very important.
It's the kind of thing that makes me want to say in a not self-serving way that if you want to test this stuff out and see if it just works, you could just go download the Mirantis OpenStack ISO at Mirantis.com and the
software.mirantis.com. If you're going to plug it, John, plug it right. Software.mirantis.com.
And download that Fuel plugin and install it and make it go. Yeah. Sounds like it could be done pretty painlessly.
I mean, and just I would have to say, since you guys are involved with the plugin infrastructure, that was a pretty easy plugin to do for us. I mean, that infrastructure is in pretty good shape. It was not a lot of effort to get that plugin built, and it was I'm very glad to see it out there, and hope that folks will make use of that and try Calico out.
Definitely, I think that's a great idea. I'm very happy to see this whole project kind of going forward. I was very excited about it when I read about it. I joke about you having lost me, but I think it's good that we're kind of moving up to this level. And also, just a reminder to everyone, we're talking about containers versus OpenStack and so on. I want to remind everybody that, let's see, this is Monday. So last chance to get yourself over to OpenStack Silicon Valley. The Unlocked Infrastructure Conference, which will look at the intersection between containers and OpenStack. It's going to be the August 26th and 27th at the Computer History Museum in Mountain View, California. Beautiful Mountain View, California. Also, if you want to subscribe to the OpenStack Now mailing list, I shouldn't say mailing list, but subscribe to the OpenStack Now newsletter, where we will give you the news of the week every single week, and you can get that by going to subscribe.openstacknow.com. Have we got any closing thoughts here, Christopher?
No, I think we covered it pretty well, and thank you guys. It was good questions.
Thank you.
And, pleasure to be on here, and hopefully maybe I'll be back at some point again and talk more about networking.
And in the meantime,
absolutely,
good luck maintaining your work balance.
Thank you.
Definitely. Thank you all very much, and we will see you next week.
Bye-bye.
Bye-bye.